Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak Nemani and this is Daily Quant with Deepak. Hi all, welcome back to day 67 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from number system. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. The link is provided in the description below. So once you sign up, you will get access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRDI and VRC. We'll be uploading 100 tests in each section, so that if you're a serious CAT 2025 aspirant, you cannot afford missing these tests. And these tests are absolutely for free, right? And without any further delay, let's get started with the first question. Now coming to the first question, HCF of two natural numbers is 24 and their LCM is 76. How many such pairs exist? Right. So let me consider two numbers to be A and B, right? And let the HCF of these two numbers be H. So let me write A as H into A and B as H into B, where A and B are co-primes to each other, right? Now HCF is H. What would be the LCM of these two? LCM of these two would be H into A into B, right? So the product of HCF and LCM, HCF is H, LCM is H into A into B. This should be equal to product of both the numbers H into A into H into B. Right. So most students apply this rule or apply this property. Right. HCF into LCM is equal to product of both the numbers. So here HCF is given to be 24, LCM is given to be 76. Now this is equal to H into A and into H into B, and they'll try to find the different values that A and B can take. Right. But they ignore the basic thing here. Now what is that? What is LCM of these two? H into A into B. So H should be a factor of LCM, right? We have written LCM has H into A into B, which means H is a factor of LCM. Now all you need to do is you need to first check whether the HCF is a factor of LCM or not. Now is 24 a factor of 76? No, right? So this is not possible. So no such pair exists. The answer for this question should be 0. So before applying this property, always you need to check whether HCF is a factor of LCM or not, right? So if HCF is not a factor of LCM, then the answer for these types of questions should be 0. Now coming to the second question, n is equal to 70 factorial into 69 factorial into 68 factorial into 3 factorial into 2 factorial into 1 factorial. Now which of the following represents the 147th digit from the right end of n? Now my hunch tells me that the answer for this question should be 0, because if it's some other digit, it's very difficult to find. But just we need to check whether it's 0 or not to be 100% sure, right? So first let's find the number of trailing zeros, right, in the product of 70 factorial into 69 factorial into 68 factorial, so on till 1 factorial. So in 70 factorial, how many trailing zeros? Trailing zeros, it should be the least power of 2 or 5, right? So in 70 factorial, in majority of the cases, right, so in factorials, we should be checking for the highest power of 5, right? So that can divide that, so that you will be getting the number of trailing zeros in that factorial, right? So number of zeros in 70 factorial, that would be 70 by 5, 14, plus 14 by 5, 2. Right. So you have a total of 16 zeros, 16 trailing zeros in 70 factorial. Now coming to 69 factorial. All right. So how do we get 69 factorial? 70 factorial by 70. Right. So we are sending 1 5 outside, because in 70 we have a 5. Right. So you will be having 1 5 less than that of 70 factorial. So you will be having 15 5s. Right. And in 68 factorial also there will be 15 5s, right? So in 67 factorial You still have 15 finds because what is 68 factorial? 69 factorial by 69. Now there is no 5 in 69, right? So 69 is not a multiple of 5. So the highest power of 5 will remain the same, right? So in 66 factorial also 15 trailing zeros, 65 factorial you'll be having 15 trailing zeros, whereas in the case of 64 factorial, now you do not have 65 here. Now because of which there will be 1 5 less. So you'll be having 14. Now so on till 60, we'll be having 14, 14, 14, 14. Right. Then from 59 onwards, you'll be having 13 till 55. 13 and so on, right? So what do we have here? 5 15ths 75, 5 14ths 70, 5 13ths 65 and so on, right? So these they add up to a number which is more than 147, right? So we can say for sure that 147th digit would be 0, right? So the answer for this question should be option B. Now coming to the next question, find the number of even factors of 60060. Now let's factorize this. 60060. Now let me write this into 6 into 10 into 1001, 6 2 into 3, 10 2 into 5, 1001. This is a multiple of 11. 11 into 91. 91 is 7 into 13. Right. So we have 2 square into 3 into 5 into 11, sorry, into 7 into 11 into 13. Right. Now what was us? Find the number of even factors. So they should be multiples of 2. Right. So let us bring 1 2 outside. Right. So you'll be having 2 into 3 into 5 into 7 into 11 into 13. Right. So the number of factors for this would be 2 into 2 into 2 into 2 into 2 into 2, which is nothing but 2 power 6, 64 should be the answer to this question. Now the other way of solving this question is finding the number of odd factors and subtracting the number of odd factors from the total number of factors. Now in order to find the odd factors, right, so you should be having odd prime factors only. So we have 3, 5, 7, 11 and 13. So the total number of odd factors would be 2 into 2 into 2 into 2 into 2, which is nothing but 32, right? So we have 32 odd factors. What is the total number of factors? 3 into 2 into 2 into 2 into 2 into 2, that would be 96. There are total of 96 factors minus 32, 64 should be the answer to this question. Now coming to the next question, what digit does A represent if 35 factorial is equal to 10333147 so on and so forth, right? Now I want you guys to understand that 35 factorial is a multiple of 9 or multiple of 3, right? Because 35 factorial is nothing but 1 into 2 into 3 into so on till 35, right? So 9 is one of the numbers. Now if 35 factorial is this should be a multiple of 9, that should be exactly divisible by 9. So let's apply the divisibility rule of 9, right? So sum of all the digits should be a multiple of 9, right? So I can eliminate these 3 threes, right? Then okay, 9, then 3 sixes, then 2 nines can be eliminated, again 3 sixes can be eliminated, then 1 7 and 2 can be eliminated, then 5 1 4 and 4 can be eliminated, then 8 and 1 can be eliminated, then 1 7 and 1 2 can be eliminated, 1 5 and 1 4 can be eliminated, then 1 plus 2 3, 3 plus 3 is 6, then what, plus 3 9, that can be eliminated, and 1 plus 5 6, 6 plus 3 9, right? So we are left with 3 and A, right? So the sum of these two digits should be a multiple of 9, right? So 3 plus A should be a multiple of 9 and A has to be a single digit number, right? So what value should A take? 6. Hence option B should be the answer to this question. Now coming to the last question, let X denote the greatest 4-digit number which when divided by 6, 7, 8, 9 and 10 leaves a remainder of 4, 5, 6, 7 and 8 respectively. Then the sum of the 4 digits of X is, right? So when you divide that number with 6, the remainder is 4, with 7 the remainder is 5, when 8 the remainder is 6, 9 the remainder is 7, and when you divide that with 10 the remainder is 8. Right. So this question is based on one of the models of LCM. Now, if you observe, the difference between the divisor and remainder is same. 6 minus 4, 2, 7 minus 5, 2, 8 minus 6, 2, 9 minus 7, 2, and 10 minus 8, 2. To answer these types of questions, all we need to do is we need to first find the LCM of these 5 numbers. What is the LCM of 6, 7, 8, 9, and 10? Right. Now let me write this as 2 into 3, 7, 2 cube, 3 square, 2 into 5. Right. So we should be having the highest power of 2, highest power of 3, 5, and highest power of 7. So 2 cube, 8, 8 into 5, 40, 40 into 9, 360, 360 into 7. So 360 into 7, that should be 2100 plus 420, 2520. Now if 2520 is the LCM of all these 5 numbers, then the required number which leaves a remainder of 4, 5, 6, 7, 8 when divided by 6, 7, 8, 9, 10 respectively will be in the form 2520k minus the difference 2. The number should be in the form 2520 into k minus 2. Right. Now we are asked to find the greatest 4-digit number. Right. So 2520 into 2 will also be a 4-digit number. Into 3 will also be a 4-digit number. Into 4, no, that will be a 5-digit number, more than 10,000. Right. So the maximum value that k can take is 3. So 2520, 7,560 minus 2, that is 7,558. Now we are asked to find the sum of 4 digits. So 5 plus 5 is 10, 10 plus 15, 25. Hence option A should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.